So guys, let's have a look at these two socket AM4 Ryzen motherboards we have. If you didn't watch the Car Booty video the other day, I'll tell you I got these off eBay together with there's two of these X570 boards. Yeah, one's a MSI, one's a Gigabyte. So they're different makes, but they're the same chipset. So I'm thinking that hopefully, being the same chipset, we might be able to find something with these, see what the situation is. They both sold us spares or repair. Both say they don't power up. One mentioned there was a problem with the CPU socket, and that's really all I know about them. So, what more can we say? Let's see if we can fix them. That's the best thing to do. Let's well, that's the, I don't know, start with that one. I'm sorry about this camera flashing. Just before I do this, by the way, I was going to mention this turned up today from AliExpress. It's a PCIe post analyzer, an LPC, and it kind of comes with a kind of a Spanglish information sheet. Is a TL460S Plus. That's really what it is. This seems to show you LPC. LPC is kind of like a JTAG type interface, if you know what that is. You find them on motherboards, so you can connect like an analyzer or something. So it's saying for Asus, ASRock, debug, whatever that is, ECS, showing you through just a few makes there. If the type of connectors you'll find on the board, and which is pin 1. It has two connectors on the end. One's bigger than the other. This says small pin. It says big pin, not big pig. Large pin. So Pegatron, I don't know, Gaymen, whatever that is, TPM. So that's sort of showing you different pins. It goes on to mention about Giga motherboards, which I think means Gigabyte. PCIe slot running code is Giga program. Only Giga motherboards BIOS code sent to the PCI slot. Other brands have the BIOS code into the LPC pin interface. Some send. Chinglish. A lot of Chinglish. Another thing I quite liked about this, it has all these like pins, like little test points here with sockets, got names on, yeah. Which is probably hard to see on this camera. And he mentions that those are for PCI resistance value point maintenance engineers dedicated. So I think this is for like either checking the resistance to Gran, that suggests, but it could be useful for checking, you know, the level of some of the, I suspect these are like the control symbols, clock, interrupt. I can see some data lines. Address data lines. Yeah, this looks like you can kind of like probe the signals on the PCI. I'm not sure if it's only for PCI or if it's for PCIe, because it has this here as well. But yeah, it's could be useful, could be interesting. LED display. So anyway, that turned up today, which I thought was rather useful. Oh, these are on the back as well, so you get that from both sides. That's quite nice. But let's try it. Let's see if that's any use. I have tried PCIe and LPC postcards before, and I didn't have any luck with them. But this is a different sort, so let's see. Okay, so that's arrived today. So the MSI. See what we have. Oh, bump. So what do we have in here? We have a graphics card, and we have eBay value customer, and we have a user manual, some bump, a sticker by the looks of it, some more bump, extender for a fan or something. I'm not really sure what that is. First I thought it was a SATA cable, but it ain't. Stickers, CD installation disc, installation guide, SATA cables. Oh, antennas. This must be Wi-Fi. Tiny little screw. Oh, for the M2. Okay, so that's what's in the box. That's what we have. I mean, I think it did mention it. It comes with what it comes with and shows you a picture. Got the I/O shield. That's quite nice. Sometimes boards don't have them. Yeah. So shall we test it? Shall we just see what it does? Can I move the camera a bit forward on the desk so I can do this a bit more easily? Yeah, I think I can. Okay. I can see that a bit straighter myself. So yeah, that's what that one's got with it. What we're going to do to test it? Well, guess the first thing to normally do is just to check the Cmos battery. That's what the first thing I do with the board. Just interesting to see if it's holding its charge. So if you've got a short in the Super I/O or the real-time clock or something, yeah, 3.06, that looks like a decently charged battery. So we can check that. Another thing I always like to check is to see how much current's being drawn from the Cmos battery. There's no exact right or wrong answer here, but quite often if you come with a Cmos battery that's completely drained, you'll find there's an excessive current being drawn from it. So I'm going to put this onto the milliamps, so microamps range. I'd expect like a board like this with just the Cmos battery. I mean, that's basically powering the real-time clock. Yes, the real-time clock on here, Crystal, is running. That's powering some part of the circuit. That's an SIO. That could be the real-time clock. North bridge under here. It could be here. Is there a south bridge on this? I'm not very familiar with AMD architecture. In fact, I haven't really looked at them. This is the first for me. I've done quite a lot of Intel boards, but I haven't really done any of these. So, normally speaking, I'd expect to find about 10 microamps on a good board. Best way to do this is to connect one end of your meter to the battery and connect the other end to the top. This, you know, where's the microscope? Where's the microscope? Let's see what we got. Let's make that a bit smaller. Oops. Yeah, okay. Cmos battery, yeah. This is the connector, yeah. So, first thing to do here. Where's the test meter? Okay. Microamps. I use this one because it's a bit more sensitive than the Fluke on microamps range. Gives you an extra decimal point. I'm expecting about 10, but it could be 1 or 2 microamps. So, positive probe on the battery, yeah. Negative one to the little terminal, and then push the terminal back so you break the connection, and the current's then flowing through your multimeter. Yeah, let's see what we get. 2.6. Yeah, that's well within normal. I think it's going to vary a bit from board to board, but anything in the range up to about 10 microamps or so, I think is considered normal. I've seen them where they draw in like 30 milliamps, and that's a short somewhere, or effectively near to a short on the board around the real-time clock. But when you find that, if this just comes from setting, the battery's going to be flat, yeah, already. Okay, so that looks reasonable. So it's obviously running the real-time clock. If the real-time clock isn't running, the board will never start, yeah. So let's try it. Try to stop this flickering. Oh, my new camera with the telephoto zoom lens and manual focus. I've just checked the shipping on that, and it was cleared through customs in Madrid on the 12th, which is 3 days ago. So that's very likely to turn up pretty soon. You know, could be. I've had post today, so it's not going to be today, but it could be tomorrow, or certainly after the weekend. So then I think we can get some really, really good videos, you know. So, what we're going to do, test it. Well, the trusty Asus PSU, we're going to need that. We're going to need to clear my desk up a little bit. I go on about this, I hate it. Just get these test meters out of the way, yeah. You can't see me, I just tidied up a bit. So okay, we're going to need the PSU, we're going to need a processor, and we're going to need some RAM. One of these said the CPU socket was damaged. Looks alright, this one. Sliding backwards and forwards. I've seen these come away here. I've seen the top broken, and I've seen them on eBay like broken. But yeah, that's okay. You can buy these sockets anyway if you need them. I keep the Intel ones in. I might have an AMD one somewhere. Sometimes when I'm buying something, I'll just tag something on the order if I think I might need it. Need a processor. I bought this specifically for testing these sort of boards, AM4 boards. This is a Ryzen 3 2200G, yeah? So what I tend to do with stuff like this, these processors can be bloody expensive, Ryzen processors. And bear in mind, I just want to test the boards, I just want to prove that the boards are working. I'm not trying to build the world's fastest gaming rig here, yeah? So what I'll normally do is, I'll have a CPU build, I think I'll put in some model numbers of boards or chipsets and find out the range of processors they use, and then try and find a processor that will work on most. So when I ordered these, I had a look and the X470 I've got, and this Ryzen 3 will work on all of them. But even these were like £100 or something. And I was looking around and I found this guy who got this one listed, and it's got a couple of broken pins on it, and I had a look to see, and the 2 broken pins are not essential. He said it's working, but there's 2 broken pins, and I went and looked up the pin out for one of these basically, and let's see if we can see them. I can't even see where they are now. I looked up the pin out for these, and I looked at the photos so I can see which pins were broken, and they weren't essential. Yeah, one's ground or VCC, and like there's loads of power pins. You're near one of these corners somewhere. There. And the other one said it's something to do with the Azalea sound clock, which is for like the onboard sound. I don't really care if that works or not. I don't think the power boards up. Oh, there, are they there? I think so. That's on this edge. Focuses. Yeah, there you go. Can you see right on this end here? 2 broken pins. So anyway, so I got this for about, I started to pay about £40 or something for it. There was people bidding on this. I'm sure I could fix that. I'm sure, I've seen it done. I'm sure I could actually solder little legs on there. If I was, using it, I'd solder some legs on, stick it in the socket, and never take it back out. But because it's for testing, they'll just break off eventually. So I didn't bother. And if it works, that's fine. We're not bothered about those extra features. Okay, maybe I can't test the onboard sound, but I suspect most of these boards are coming in dead. Okay, so let's go back to the desk. So we need a processor. So we've got a CPU. Yeah. Does it want to fit on the board? Is it the right way round? No, it's the wrong way round. Yeah, just dropped in nicely, so that's fine. Just pushing down on its socket looks fine to me. Maybe it was the other one that said it had a broken socket. Okay. We need some RAM. Corsair Dominator. These 2 are actually out of one of my gaming rigs that I've built, but I need a GPU, so it's sitting on one side till I can get a GPU at a sensible price. I'm not bothered to wait. If I wait till next year, I don't really care. This machine's been built out of second-hand bits that I've fixed over time. It's actually X99 LGA 2011 with an overclockable i7 in it, 5820K or something. So yeah, it's waiting a decent GPU. It does work. I've tried it with a GTX 960. Where did he go? So anyway, yes, I took these off my gaming rig, but I just managed to get the other day for like 20 quid a couple of the Corsair ones. I used to have some in the workshop, and I ended up using to build a PC in the workshop. That's why I needed to borrow these. hopefully the other ones will turn up soon. So yeah, this sort of thing, if I need it, or I know I'm going to need it, go on eBay and watch for auctions. Just go to the latest auction and have a look to see what's the cheapest price that anybody's actually managed to pay on these things and bid that. And 9 times out of 10 you won't get it, but if you're not in a rush, just keep doing it and doing it and doing it, and sooner or later you'll get them. Yeah, a couple of 4 gigs or something. I've seen them go as cheap as £16 for 2. Unfortunately, I missed that auction, but I managed to get a couple for 20. Plus the £16 ones were kind of like no brand, and these are the ones I have, of course. Again, get the slowest ones, 2133s. Yeah, I mean these are 3000s. This is off my gaming machine. I got 4 of these for about £80. You know, about 20. It wasn't a bad deal. Used, obviously. Yeah, which slots do they go in? That's a good question. I can't. In fact, no. Let's not even put them in. If we don't put the RAM in and power this up, it should like bleep to say there's no RAM, and that's a very good sign that a board's actually booting. Yeah, and if it's actually booting and bleeping with no RAM, then fit the RAM. If it don't boot and bleep with no RAM, it probably isn't going to work anyway. Oh, it's flashing bloody camera. I'm sorry, guys. Come on, bring on the new one, please, guys. In Madrid, send me the camera. Okay. CPU. We need a cooling fan. Again, I'm only just powering this up to see if it boots. I don't have an operating system. Yeah, this is what I use. These legs are short, and normally you can rest it on top of the CPU with a good clearance from the board, so you're not going to short anything out. So we'll stick that on it. I know some people will shoot me down in flames for doing this. I believe on some older AMD K6 and them sort of old processors, retro, which have a very small little square die in the middle, and some of the Pentium 3s, it's not a good idea because the die is so small that you haven't got much of a, you know, an area to transfer the heat. But these things with big metals on them, it's good enough, you know, for testing. Where's this thing? Plug in pump fan. I wouldn't be surprised if you don't put a fan on that it won't boot up, you know, because it detects the fan spinning. So this says pump fan. I don't think I want that. I want CPU fan. I could read the manual, of course. I could just read the manual and find out where the RAM should go and all the rest of it. Okay, so I've that on there. Power. Not too difficult. Power. What we got here? We got a 4-way and an 8-way. Pretty sure this power supply has the right connectors for this. 4. Oh, I know there's an 8-way on it somewhere. If you remember, I was playing around with some cards. I needed like a 6 and an 8 on graphics cards. I had to botch that one to work. But yeah, here we go. Here we go. So an 8. Bang my head. 8-way down there. Yeah, one more thing I think it's worth testing on this before we power it up is, do we have a short on here? I'm not so bothered about ones down here particularly. Probably is worth checking though. But do we have a short on this? Because this powers the VRMs, and if you've got short circuit MOSFETs down here, if you use a decent power supply, a good brand, it'll just shut down. A cheap one, it might blow the power supply. It certainly won't do the board any favours. It certainly won't do your processor any favours. That's the thing. If you've got short circuit high side MOSFETs in the VRM, your CPU is now toast most likely. So from the yellow here, all the yellows should be connected together. So just from any of the yellows, we're on ohms range, and we'll go to ground somewhere on the thing. No, we don't have a short. That's good. That's a good sign. Just check from the other one. No, we don't have a short. That's good. No shorts on there. Let's go for the 12 volts on the front edge here. Yeah, that's good. Let's go for the 3.3 as well. It's not a short. 23. It's 23 ohms. Yeah. My light's reflecting too much on that for you to see it, isn't it? 23. It's not a short on the 3.3, but some parts of the North Bridge and stuff will be on the connected to that. Where's standby? I think the standby's a purple one. Yeah, nothing on that one. Or is it the green? I think it's the purple standby. No shorts there. This is probably the 5 volts, so I'm guessing this is the 3.3 volts. Yeah, I don't call that a short. I mean, come on, we've had GPUs at 0.6 of an ohm and they're not short. If you couldn't see the meter before, that's off the 12 volt connections. Okay, no shorts. I'd say that's safe enough to switch it on, you know. Straighten the fan up a little bit on the processor. Okay. Yeah. What else we got? Well, switch goes to JR4 Rainbow. It's got like rainbows. It's got like internal lighting or something on this. I think this is the power switch. I'll tell you what. I won't put it on for now. I'll show you how to see if that's the power switch there. This looks like it's a speaker. Oh well, it's marked something. What's it say on here? I think these markings here refer to this one, you know. Yeah, and it says that's the power switch. Yeah. I'm sure that's the speaker, but I'm just gonna check that just to be 100%. Oh. Box fell over and hit the microphone cable. Fortunately, didn't lose the microphone. Let's have a quick look at this manual and just see all the quick guide installation. Skip forward to the interesting stuff if you want, guys, but you know, I'm showing you this is out of the box, unknown entity. So I'm sure you'll learn something from watching this, how to do it. That's just pretty nerve. Oh yeah, it shows me the power switch, so I know where that. I guessed it right. Doesn't seem to mention a speaker. $18. No particular mention of a speaker. What's it say? Something here that tells us what these things are. Power connectors, have a look. Power switch. Is there a speaker built on the board? Sometimes like a little buzzer. I can't see one. And it's worth finding the speaker because obviously that could tell us quite a lot about what's happening when we power this up, you know. What diagram? Oh yeah, here's a layout. JFP2 front panel connector. It just says that's a front panel connector, but it's got 4 pins on and all the rest of them are here. That's got to be the speaker. Can't see that being anything else but a speaker. Yeah, stick a speaker on that one. Fingers crossed, but I'm pretty sure that's a speaker. Yeah. So it's got on board. Yeah, it's got HDMI out. So yeah, okay. Borrow the HDMI out of the microscope. That's what I normally use. Won't reach. One moment. So it's HDMI cable. That'll reach now. HDMI, so we should, if it's working, we should get a picture, we should get a bleep. Should we stick that postcard in? Man, I've never used that before. Let's just power it up first and then, depending on what does or doesn't happen, let's stick the postcard in. Okay, yeah. Normally that postcard, I test that on the known working computer first to see what it does, but it's only just arrived and I'm just too tempted to, you know, I want to try it. Power. Everything's looking good. No crap on the guess it can be shorting anything out? No. Sometimes it's worth balancing this on the box actually it came with. It came in. Okay, that's good. Power. We're on. Boom. No, nothing. Not even power supply switched on. All the leads are connected. Nothing. Nothing at all. I'm gonna call that dead. That's dead. Okay, let's have a look. Voltage. Right, first thing I'm going to do is check to see if there's standby 3.3 coming on here, which I think is the purple. I might have to just go check that. But no, it's a purple. It's a bit of the green. Set to ground. 5 volt standby coming in. It's not 3, but it's 5 volt standby coming in. Nothing else. Just in the yellow. No, nothing else. That's not starting. It's on the green. This is your effectively your pin that your ground to start a power supply plant. 4.9 on there on the green, yeah. So let me show you. Let me show you. Let me show you. I know this stuff, but I've got to assume you don't. So you want to learn. Maybe you do. ATX U connector. Yeah. Green one's the power supply on. You see that's got like PS underscore on, power supply on, and a little hash, yeah? This little hash, when you see that little hash, it means that has to be connected to 0 volts ground to activate the power supply. So power supply on hash means it's active when it's low, yeah? It's active when it's 0 volts, and that's got about 5 volts on, okay? And purple one, 5 volt standby. So what I've got on this board is I've got 5 volt standby going in. Let's get back to the camera again. Desk. Here we go. So I've got 5 volt standby coming in. Just connecting the back to ground. Anywhere I can find the ground. Five volt standby. So there's. I was actually wondering about. There was 5 before. I've got a bad connection to ground there. Yeah, I have. I'm just connecting down here instead. Also a bad connection. 5 volt to ground. 5 volt standby, yeah. And this pin has got 5 volts on. And to signal the power supply to turn on, yeah, to signal the power supply, that green, which is what the meter probe in the green, needs to go to 0, yeah. So when I press this switch, that should go to 0. And quite clearly nothing happens. So it's never sending a signal to the power supply to tell it to switch on. Yeah? You can see that. Nothing happens. So what we can do here, easiest way, is just take the meter probe off, yeah? And I've still got it stuck into the green wire, the end of the meter probe in the green wire, yeah? And I'm going to connect this to ground, yeah? And that'll tell the power supply to switch on. And I want to see what happens. Does it switch on? It should do. Yeah. You see it now? Try that. The switch is on, yeah? There's some LEDs down here. I don't know if you can see them. Let's move some wires. Yeah. There's some LEDs here, yeah? Let's get a good connection to ground. Yeah, it's running. You might be able to hear the fan. You can probably see this fan running, yeah? and the first LED is coming on, which is CPU. So that's what it's doing. I'm sure this manual somewhere I'll tell you what those LEDs are and what they mean, yeah? I'm sure it will tell us what that means. Debug LED 39. Probably telling us there's no CPU, well the CPU isn't running. CPU indicates the CPU is not detected or failed. So it's either telling me there isn't a CPU in, but we know there is, or it's telling me that the CPU's failed. But I'd take that with a pinch of salt, that the CPU failed. It could just mean the CPU isn't running, yeah? And considering that when I press the start button, no signal comes to here, yeah, to tell it to turn this power supply on, you can pretty much guarantee that also no signals going elsewhere. We can try that though. I mean, it's possible. It's just possible. No signal gets to here, but the signal gets to the CPU, and I need to hit the start button to make it run. So again, let's just go. You don't need the voltmeter. I'm just connecting my meter lead from the green to ground. Yeah, it's turned on. Now I'm going to press the start button. Nothing happens. This red LED stays on. Yeah. So that will not start it. So I think probably when I press the start button, it doesn't send a signal. Okay. Why doesn't it send a signal? Where do we start? We start at the start button. Now, on the pins that go to the start button, yeah. These are the pins that go to the start button, yeah. And the 5 volt standby, which we know we've got on the purple wire, should come to here. It might not be 5 volts when it gets here, it might be 3 volts, it might come through a voltage regulator. But on these pins here, the start button, can I focus that? I'm sorry. New camera, please arrive. When I check from ground to these pins, one of them should be 3.3 or 5. Yeah, do it with the wrong way around, black to ground. Yeah. 3.3. The other one will be ground, yeah. The other one next to it is a reset, so I'll look at that one as well. That might just have note on it for now. Yeah, nothing on that. Sometimes that's got 3.3. Okay, so 3.3 and ground, yeah. That's I mentioned before. I said I'll show you how to figure out where the start button goes if you haven't got a manual and you can't find out. And the answer is the pin that's got 3.3 when it's not switched on to ground. That's where the start button goes. So we've got 3.3 here, and I'm sure we can see quite clearly if I can get a connection onto the. Let's do it on the switch. Easiest place. Told you a good reason for having a switch, didn't I? On the switch. 3.3, yeah. When I press the switch in, that 3.3 will go to ground. But all that's going to prove is the switch is working. We know the switch is working. But basically, 3.3 ground, yeah. 3.3 push the switch ground, yeah. So we know the switch is signalling to the board to tell it to turn on the power supply. It's not happening. So, what needs to happen for that to happen? Well, this is going to vary a bit from one chipset to another. But the chips that are involved in starting a board up from scratch, yeah, and normally the Super I/O, yeah, which normally controls all the VRMs or tells them to switch on and tells the board to power up, yeah. The Super I/O is what normally, I'd have to check this chipset, but probably pretty certain that's what will do that, yeah. That will tell it to power everything up. When it's all powered up, all the voltage rails are up. This will basically signal to the North Bridge and South Bridge as well, usually. So generally all three are involved before you can power a board up. That's involved, the North Bridge is involved, and the South Bridge is involved, yeah. So because they're all involved in powering the board up, that means that there must be standby voltage on this, yeah. There must be standby voltage on the switch, yeah. There must be standby voltage on the north bridge, and there must be standby voltage on the south bridge, because otherwise it can't start. You may find some chipsets that are different to that, and you have to read the chipset data sheets, but that's generally the case. So what we need to figure out first is have we got standby voltage here, and have we got standby voltage here? Because I can't see a south bridge on this. Maybe AMD don't use a south bridge. Maybe this is north and south bridge, and I know it's going to be under here because there's a fan on it. Maybe that's both on an AMD. So yeah, we could look up the data sheet for this chip. We could see what it is, and we could find out which of the little legs has got standby voltage on, and we might have to do that. But the easy way to be like 95% sure, probably more like 99% sure, is have a look around the capacitors in this area and see if you can find a 3.3 or a 5 volt, yeah? 5 volt standby coming in, and there's almost certainly on here, because I measured 3.3 here, I measured 3.3 on the switch, there's almost certainly someone here, a voltage regulator, that's dropping that 5 down to 3.3. So I'm expecting to find 3.3 here, and some voltage, 3.3 or sometimes 1.8 on the north bridge. So there might be another voltage regulator involved. I wouldn't be surprised. That it could be 3.3 standby, but I suspect it's likely to be less. So let's go to the microscope, because that's the way for you guys to be able to see what I'm doing here. Yeah? Let's go back over to the microscope. Well, I've got the microscope camera working again, but I just realised before we do that, we're going to have to look at voltages under here and around here. So just need to take this heatsink off. Fancy looking things they fit these days. I'm guessing that's there. It does go down some more. I thought it was going to be some under here. So let's just doesn't fit. Let's find a screwdriver that does fit. Dig around in the box a bit. There we go. Should do the job. Yeah. So we need to take this off. Put these safe. Okay. Is that loose? Yeah, it's off. It's off. There's like a little connector here for the fan. That's out. That was easy. Okay. Bit messy, but there's our north bridge. So can I reach the? One moment. I'll have to go down the Chinese shop and buy myself one of the audio, like, you know, a 3.5mm jack extender from the Chinese shop. A bit lucky, it might even work. Just clean a bit of this mess off this. One moment. Okay, phone calls. Wasn't even somebody wanting to buy something. That's not so good, is it? Okay, so yeah, so we've just moved the crap off that. I've taken the heatsink off just for the moment. I'll need to put that back on though. Actually, yeah, I need to put the heatsink back on because I have to measure some voltages. No, we know the CPU isn't running. We know it's not even powering up. So no, I don't need these. Not for the moment. Not until we actually get the board to switch on. We know the power supply isn't even sending any power into this, apart from standby. Okay, no more messing. Let's go and get the microscope camera, and let's have a look, see what's what, and see what we've got on this board, and see why, hopefully why it doesn't power up. Microscope's working, that's a good sign. Okay, so, as I was saying to you, this is the Super I/O, yeah? You'll find these on every sort of motherboard, different chips, but you'll find the Super I/O, yeah? And the main role of the Super I/O NCT 6797D Nuvoton. The main role, well, not the main role, one of the roles of this chip is to power up the board. It's involved in the power on stage. This is what connects to the on-off switch, and this is what sends signals to the power supply to switch on. You may not send them directly. The north bridge will be involved, and possibly the south bridge. Sometimes the real-time clock's built into this, depending on the chipset, but I don't see any crystals around here. So I'm pretty much guessing that in this case it's not. I'd say the real-time clock is in the north bridge. Okay, so what we're going to do. Power supply is plugged in, turned on. Yeah. Let's get our other camera so we can actually see. Let's go back to the desk cam. Hopefully we can make this. Well, yeah, there we go. Nice one. Okay, desk cam. Meter. Volts. Yeah. So you can't see this on the microscope. All I'm just doing at the moment is just checking on the 5 volt standby coming in. Should be there. It was there before. 5 volts coming in. Yeah, 5 volt standby. So we've got 5 volt standby. Right. Somewhere on this board that has been dropped down to 3.3. I could probably have a poke around and find out where it is, but I'm not going to. I'm not bothered because I know there's 3.3 on the on-off switch, so I know that's working. Because there's 3.3 volts there, so I'm not interested in where it happens. What I am interested in is whether there's any 3.3 volts over here. And the first place to look at that is going to be on capacitors. Because if it's on the capacitors, the chances are it's on the pin. Without me looking at the datasheet for this. So I don't know which capacitors, but let's have a look what we got. Oh, well that was a good guess. 3.3. Oh, it's there. So any of the other ones? No. I just went for the biggest one I could spot first. 3.3, and of course the other end will be 0, could be going to ground, yeah? So there's your 3.3. And we can very confidently say, we might even be able to see where it goes on, just with the zooming in on the microscope, we might even be able to see that goes to the SIO, but we know it will do. It does, don't it? You can see it. Let's just get some zoom on there. Yeah, there you go. You can see the 3.3 goes here, yeah? So we know there's 3.3 volts. Can you see that track? I'm sure you can see that track from the end of there to there. So we know 100% we got 3.3 on that. I was pretty confident we would have because we had 3.3 on the on-off switch, and that's where it comes from. Okay, so that's there. Second place we need standby. The north bridge. Where are you? There, north bridge chip. We need to have standby here, yeah? Quite often this is a bit lower, it's quite often 1.8, it could be 3.3, depends on the chipset. The more modern boards seem to be a bit lower, maybe even lower than 1.8, 1.1 maybe, don't know. So I'm connecting the meter from ground, and again I'm going to look on the capacitors on here to see if I have any voltage coming in. Bear in mind this north bridge and that Super I/O will have more than one power supply. So you won't expect there to be power on all of the capacitors, just the ones that happen to be on the voltage rail. That there's a standby, nothing there. We don't know which end of them is ground, so we have to check both ends. Nothing there. I'll look over here. Maybe try one of these. I'm going to look down the microscope. No, I can't look down the microscope because I can't see the bloody meter. I really want a microscope with a HUD, a head-up display with a meter. That'd be fantastic. Nothing there. Oh, nothing around so far. It's over here. Nothing there. There's got to be some voltage on this somewhere. Otherwise it can't work. This could be a good reason why it doesn't boot up if there's no voltage here. Sure I've got a good connection on the ground. I'm not 100% sure I had. Maybe the meter probe had slipped off. Well, in fact, I'm on the ground again. I'm just going to check back on that capacitor over on the over by the SIO. Yeah, I've definitely got a connection to Gran, so I've got voltage there. Nothing. Something there. 0.31. 0.318. I keep losing the connection, but it's there. Clean and the remote probe is a bit of heatsink shit on the end of the probe. 0.318. Yeah, this is fair. That's low. Maybe these very modern boards they do. I mean, anything else around here? No. What's up here? No. Have a look around a bit further up. So all I found so far is down here, this 0.318. Where was it? That one. And that one. That doesn't seem right to me. What have we got over here? Well, I'll tell you what we can do. We can have a look around, then we can see what the other. If we can't make any sense of this, let's have a look at the other board. Nothing there. There's the 0.318 again. So this 0.318 seems to be getting quite a few places on here. I'm going to have to use the microscope, guys. I can't do it like this. Not easily. So 0.7 glasses on. There's something there. Top one, I think it was. Because you've got to be careful when you're doing this, not to short to another capacitor as well, you know. Zero 0.7. Well, it's a bit more. Okay, I've got some voltage on the north bit, as I said, but from my own experience, that doesn't look right to me. Those voltages are very low. But I've never worked on these boards before, this chipset. So what I'd be interested in doing is is the camera working yet? Have a look at the other one, see what that's doing. So yeah, we know this one. We know this doesn't power up. Yeah, we know we've got like 0.7 and 0.318 on this, which to me, I don't know the chipset. I've never seen them that way before. Okay, that's something to look at, and it doesn't power up. Okay, let's have a look at the other board. See what that one does. This is the beauty of having two. I mean, I know they're different makes, but they're the same chipset, so they've got to be very similar. These boards have, you know, plastic thing off the screw that holds the north bridge heatsink on. Right. Yeah. I want the CPU. Okay, stick that one on one side for a minute. Find somewhere safe to put that. Up on the shelf, out of the way. You stay up there, okay. Let's have a look at the other one. I've never seen a north bridge on standby less than 1.8 personally, although I suspect I might see them around 1.1 because I've seen supply rails on North bridges when they're running at 1.1. But I have to say, I've never seen a supply rail on the North bridge any less than 1 volt or 1.1, even on the working board of different chipsets. And that's why. Oh, okay. There's your broken CPU socket. Said didn't I there was a broken CPU socket. Let's have a good so, microscope. Yeah, didn't say one of them's got a broken CPU socket. Microscope. Okay. Well, the top's off it, and I can see some damage here. Here. Some bent pins. Okay, so yeah, we have some damage in the socket, and then the top's missing. The top's come off altogether. Can we get even a focus on that? It didn't look too bad. I mean, I think the way these things work, because you know, like when you plug them in, like the top kind of like slides backwards as you sort of clamp, you know, the little handle down. And I think how these work is the pins sort of go in like in the front of this, and then when you push the latch down, they push back. The CPU pins push back against the pin. And although these are a little bit bent, there's no broken ones. And I'd imagine that would work. You know, once you put the if you can get the CPU to stay in the socket, I think that would probably work. The problem is, this is broke off. Let's go back onto the desk cam, see if I can do anything with this socket. It's a bit too zoomed in on this to be able to really see what we're doing. Yeah, so that's the lid. Like a little handle has like a little lift up thing here, and I can see that sort of goes in, should go into like a little notch here, and when you put the handle on it pushes this slightly forwards, which I think is what pushes the CPU pins against those sockets. You can quite clearly see now the damaged ones there, yeah, but under the microscope they don't look like they're that badly damaged. Can we get this to go back on again? Under there. Yeah, okay. So, can you see? No, but I don't know if you see. You see the flash as it goes past the pins, yeah. So this slides forwards a little bit. Say like all the retaining clips have broken off, which is why it fell off. But if you push it down, I think that might work. Okay, let's try. Let's see if the CPU will actually go in. Yeah, CPU dropped in. Let's just clean the shit off it a little. Shit. Clean the heatsink compound off it a little bit, because I want to put my finger on it and push downwards. At the same time I operate the socket lever and see if it'll actually grip the CPU. But yeah, this one, that's a good enough reason for this one to be faulty. Okay, just pressing on the CPU and I push down on the back of the socket. Right. It clicked. Back of the socket's lifted up a little bit. Oh no, it's not too bad. Oh yeah, you can see where it's broken there as well, so I've got a little bit of plastic's chipped off that. But CPU's in. CPU's firm. Oh, it's fairly flat actually. Let's bring it back again. Yeah, click. hold the CPU. Let me just, I'm going to hold one back on this back edge down a little bit this time. Push it into place. Yeah, same thing. I've got kind of like a little gap. Hopefully you can see that on the back of the socket, like a little gap. But it seems to be held in place. Okay. Same checks on the other one. Let's just look then. Do we have any short circuits, especially on the 12 volts coming in? Yeah. So resistance range. Ground somewhere. I'll just find the ground. There's lots of grounds on the board. Ground. One side this will be 12 volts and one side this will be ground. If I've got a connection to ground, that is. Nothing. Meter's working. Maybe I don't have a good ground connection. Try with another one. Let's try this one over here near to the thing. Yeah. Nothing. Yeah, one side you expect it to be shorted to ground because it's the 0 volts. Yeah. And the other side is the 12 volts coming in. So there's no short on there. That's good. Okay, no shorts there. Let's stick the ATX power connector on. Power supply's turned off. Yeah. Stick this thing in here. 12 volts. In. Okay. What we got? ATX power. So there's just a 1/8 way on this one, even though it's the same chipset and the same processor type. These think that 8-pin power will do the job, whereas the MSI thought you needed 12 pins, 4 and 8. Is that overkill or was this underkill? I don't know. I think that's it was just overkill. So we're going to check now on here. So we're going to check from the purple, which is standby. We go to one of the blacks. No short on the standby. Yeah, that's really much like the other one on the 3.3. That's good. Yeah, reading on the 12. It's on the green. No shorts on that one. Red. Yeah, especially that one reads. The other one about like 20. This was slightly lower, but that looks reasonable. Okay, I think we can. We put a CPU heatsink on. That's what we can do. We can put a heatsink on the CPU. Just that I'll hold it in place as much as anything else. Whack that on there. Where's the CPU fan here? Yeah, CPU fan. Where's the? Oh, this one's marked quite easily. Speaker. Power switch. This one's marked nicely for us. You can't see that, can you? I'm off the camera. Sorry. Speaker, power switch. I'll just go back the way. Let's move the camera over a bit where it's a bit more comfortable for me to work. Okay. Up a bit. There we go. So yeah, that's looking good. There's no shit on the desk. Nothing shorting out here. This is why you keep your bench clean. That looks pretty good. Turn the power supply on. Let's have a look to see if we've got any 5 volt standby on this. That'd be interesting. So power from here should be standby now. Oh, voltage range. Standby, yeah, 5 volts. 3.3 volts on the switch. Should be good. Can't even put the thing where you can see the damn thing. Oh, this one's at 5 volts on the switch. The other one had 3.3 volts, and then the switch fell off. So this has a 5 volt standby. The other had 3.3, but That's probably because it's got a different sort of super IO. Where's the super IO on this thing? Can't see it. It's not this. I'm sure that's the audio chip. I'm sure. Can't even see the super IO. It must not be. I wonder if it's under here. Well, that's the North Bridge. You never know. Maybe it's under here. Okay, so I think we best shall see what this one does. Power supply on. Push the switch, and it powers up. No beeps. There's no ramming, so it should beep. No lights on this one. Maybe there aren't any lights. Oh, that seems to power up, but nothing else. So, the CPU doesn't really feel warm. The CPU feels cold. I'd have thought if it was running, the CPU would have a bit of warmth in it. Let's connect video. Let's connect the monitor to it. I'm assuming this, you've probably got some connectors on this. Oh, HDMI, there it is. HDMI, power supply on. It powers up, sort of. Nothing on the monitor. Let's go to HDMI on the monitor. Well, it wouldn't be anything on the monitor anyway because I've got no RAM in it. And this is how that CPU socket looks like it's broken. Maybe there's a problem. That powers up, but nothing seems to happen. It doesn't bleep. Well, let's stick some RAM in it. I mean, I can't imagine this will work if it doesn't bleep without any RAM. Do we have a manual with this one? Yeah, we do. We do have a manual, so see which way the RAM goes. The fact this doesn't bleep without any RAM tells me this isn't actually booting up, it's just powering up. Yeah? But unless there's something stupid wrong where I'm not getting any sound out of it, which I can't see because it's got a speaker connector on it, so let's have a look. RAM A1, A2, B1, B2. Pretty sure A1 and B1 will be what you need to fit first. Well, I think so. Let's find fitting the RAM. So it says about installing RAM. It's got to tell you somewhere here how to install the RAM. You there's BIOS setup. Sure, it tells you somewhere here how you install the RAM. I mean, maybe this one's working, you know, it's just that CPU socket just broke on it, basically. Installing memory, page 9. It tells you somewhere about it. Page 9, what does it say? Page 9. Yeah. Page installing memory. Read the following guidelines. Ah. Aha. So, we go with A1 and B1, which is what I said in the first place. Or A2 and B2, it doesn't matter. Okay. Well, since I can't easily get this thing in here because of the cooling fan, let's go to A2 and B2. A2. B2. A2, B2. Power supply on. Now let's see what she does, eh? Powers up. Oh, fan slowed down, that's a good sign. It's like it's got control of the fan. Still no bleeps. Nothing happening. Doesn't appear to be trying to boot. No lights on this one. Let's take our who makes this thing? Gigabyte, yeah. Let's try to stick our post analyzer card in it, because it mentioned that Gigabyte actually used the PCI. If that's understanding the Chinese English manual. Well, that says I've got standby power. There's a little green LED on it. 0, 0. I've got 0, 0 on the analyzer card. Either it's not, and there's nothing else lit up though. CPU, DRAM, VGA, nothing lit up. Just as this standby, I know it's powered up. Okay, so that one doesn't basically seem to power on. But what we can do is check the voltages, because I know the Northbridge chip will be the same, because it's the same chipset as the other one. So let's have a look and see what we got here compared to that first one. Because for sure this one powers up. Okay, probably need to take the heat sink off to get at it. Let me just check in, is this processor warm? Not so you'd write home about. No, not really. Doesn't really any warmth. I wonder if the V-Core supply isn't running. That's the next thing we'll have to check with this. Have we got any power to the CPU? Could be socket's broken, it's not detecting the CPU. I'm not sure how reliable that socket is. But it looked like it's holding the CPU okay. It seems to be sitting flat in the socket. Right. Oh, spring loaded thing sprung off. Little plasticky thing. Also, this got 5.5 volts on the on-off switch, and the other one only had 3.3. I don't know if that's related, but 3.6 is quite normal on the on-off switch. So it depends on the SIO, really. Let's see what's on this one. What was it on? A Nuvoton something or other? We can have a look. Okay. Okay. Oh, these things are flirting all over the place, but I've got it. Okay. Right. Let's have a look at that. So what we got under here? Fan cable holding it down. Goes here. Looks like, yeah. Right, there's a Super I/O. Sorry. There's a Super I/O. Yes, I couldn't see a Super I/O, but it must have one. This is a ITE. It's a different chip. This is the Northbridge, which will be the same as the other one because it's the same chipset. Okay, let's get this one under the microscope. Let's put the CPU cooler back on. Well, it doesn't seem to be generating any amount of heat, to be honest. Go on there. Microscope. Let's minimize. Well, not minimize. Let's make the little window again with the desk camera. Go. Stick the test meter somewhere where we can see it. Yeah. Okay. Right. We know this one power. We know this power's on. We know the microscope camera's frozen yet again. Let's see if we can get that back. Okay, so we've got the microscope camera running again. Let's see if we can just power this board up. I've got no heatsink on this now, but I don't think it'll get very warm initially while the thing's just power, sitting there idle. Well, it is getting warm, but it's not. No, that gets warm, that does. Okay, what we'll try and do is we'll try and switch it on and quickly take these voltage readings. So I think on the other one, somewhere around here I had like 0.3 and up here was about 0.7, yeah? So let's do this so you can see what we're doing. Where's the desk cam? I'll probably have to alter the order of these. There it is. So we're going to check, I believe it was here where we had 0.3, yeah? Let's clip the black lead to ground. So what I can then do is I've got one hand to hold the meter probe on here, and the other hand's free to turn the thing on and off, yeah? Because I can feel this getting quite warm, and I obviously don't want to do any damage to that, yeah? Let's see where we can get the get this thing on the ground somewhere. We've got a connection there. Let's have a look. Resistance. Nope. I just need to get a good connection to ground, basically. Nope. Okay, lead fell out the meter. No, I need to find a good ground connection. Just give me a moment and I'll find one. Okay, I found a ground connection by clipping the lead to the I/O shield actually at the back. Struggling to find somewhere easy to clip on. I could have sold a little bit of wire. Just makes life easier now. So I've got one hand on the probe and I've got one hand on the switch. Yeah. So this thing doesn't get hot while we're doing this. So I have a connection to ground, pretty good. Volts range. So this is where we want to have a look now at this. So I think it was on here where we had the 0.7. Yeah, and we're just going to switch it on. Oh, yeah, because you don't need to switch it on because you only need it in standby. Ah, it doesn't even need to be switched on. It just needs to be in standby. Yeah, because on the other one in standby, I was only getting 0.3 and 0.7. So it's in standby now, so we don't need to get this hot at all. Okay, of course. And what did I have here? 1.01, and the other one was like 0.3, and what did I say? I've never seen one as low as that. 1.01, and the other one's 0.7 up here. Was it here somewhere? 1.8, right, that's normal. 1.8 and 1.1, was it something like that? One point eight and 1.0 basically. Okay, so that's a good one. That's what we've got. And the other one is a bad one. That ain't what we got. Okay, guys, desk cam. That's interesting. Now we found something we can look at. Just make this camera window a bit bigger. Sorry, let me just get hold of the damn thing. Yeah. Right. So that's interesting. We found the fault on the other one. Standby voltage is way too low. Way too low. Let's see if we can figure out why. So this one, we know it powers on but doesn't do anything. I suspect there's no power to the CPU because it's not getting warm at all. This is getting warm. We need to investigate that. But let's put this one on one side safe for a moment. Just give me a moment. this is the other one. So where's that voltage come from, that 0.3 and 0.7? Good question, but I suspect it's coming from here somewhere, because I can see here two little buck coil regulators, and there's something else here as well. One moment. Okay guys, so where were we? Although a second's gone by for you, I had to actually go out on site to a customer who's having problems, so an hour more's gone by for me. But we're back now, and I recall where we were basically. So this is the board that doesn't power on, and we know as a fact, we know that this North Bridge, or PCH, whatever you want to call it, platform control hub, I believe that stands for PCH, has only got 0.7 and 0.3 volts on it, and I said that seems strange when I first saw it. And we looked on the good one, well, say good one, the one that does power on even if it doesn't work, and that had 1.8 instead of 0.7, and it had 1 instead of 0.3. And I thought about it actually while I was out, and it just occurred to me, so probably could have job a little break. I thought, well, if the good one has like 1.8 and this has 0.7, that's a little bit more than a third. Like, you know, 0.7 is a bit more of a bit more than a third. Like 0.6 would be a third of 1.8, so it's just over a third of what it should be. And 0.3 is slightly less, but the other one had 1, so it's a bit less than a third. But they're both, roughly speaking, about a third of what they should be. So then you've got to think, well, where does that voltage come from? Where does the 1.8 and 1.1 come from? And on this, why is it wrong? If you think about it, and I'll give you 10 seconds, have a think, where does that voltage come from? Okay, have you thought about that? Well, if you thought about it and you thought about it right, there's only two places that voltage can come from. One is the Cmos battery, which has got 3 volts in it, and one is a 5 volt standby on here. Yeah, and in theory it could come from both. I'm telling you now, it ain't the Cmos battery, and the reason it ain't the Cmos battery is because that only powers the real-time clock, and it doesn't go through voltage regulators. I'm pretty sure it might do, but I don't think it powers certainly 2 voltages on this. But we could be sure, you know. What we could do is, in fact we can do it now, we've disconnected the power supply. The Cmos battery is still there, yeah. So don't take my word for it. Let's see if those voltages are still there. Let me go over to well, go over to anything. There you go. So we're on voltage now, yeah, and we're going to measure to ground, and we're going to come from the Cmos battery, and we've got 3 volts, yeah. And then we're going to go to see where we saw the 0.7 on this chip, and it's now 0. And we're going to go to where we saw, sorry, the 0.3 that was, the 0.7 was up here, and it's now 0. So it ain't the Cmos battery, yeah. And the only other place left that can possibly come from is the 5 volt standby, because there's no other voltages coming in on this, yeah. So where does it come from? There. But that's 5. This is, well, it should be 1.8 and 1.1. And that's 3.3 over there. That seems right because there's 3.3 on the switch down here, yeah. So that seems right, but these are wrong. I'm labouring the fact, aren't I? I'll tell you where it comes from. It comes from voltage regulators on here. So that 5 volt standby is running some voltage regulators, and I can see here there's one here, there's one here, there's one here, there's one here. That might be one, but I don't see a coil there. But there's a group of voltage regulators down here. I mean, there's some more here, but they're probably for the RAM, and there's one over here, and these are your VRMs, they're for your V-core. That's, I don't know, something or other. But I suspect that one of these here, or 2 of these, are powering that, you know. Let's think about this. We've got a fault, yeah, we've got a fault. It's most likely the fault is on one component, yeah? Which tells us that either we've got one regulator that takes the 5 coming in and gives 3.3, 1.8 and 1.1, and the regulator's faulty, so only the 3 volt output's generating properly. Or we've got more than one regulator, yeah? So you've got 5 coming in here, you've got a regulator for the 3.3, the 1.8 and the 1.1. But there's 2 of them that aren't working. So there could only realistically be one fault. I mean, there could be more than one, but it's not so likely. So the only realistic explanation for that is 3.3 volt comes in, yeah? It goes to the 5 volt standby comes in. It goes to some regulator somewhere and puts 3.3 volts over here, yeah? It goes to another regulator and puts 1.8 on here. And then from that 1.8, it goes to another regulator, and that derives the 1.8 into the 1.1. So, if your 1.8 is low, about a third, 0.7, your 1.1 is going to be low, about a third, 0.3. Yeah? Yeah? Just think that, yeah? And that is the logic that tells me I've probably got a regulator on here that should be generating 1.8 that ain't, it's giving 0.7, and then that 0.7 is going to another regulator which should give 1.1, it ain't, it's giving 0.3. And I think that's most likely what we got. I love doing this, I love telling you what I think it is and then proving I was actually wrong, yeah. It wouldn't be the first time, you know, but anyway. Let's see first, tell me where this comes from. So I've got no power coming in, power supply disconnected, yeah. We're going to go on to resistance range, yeah. I'm going to have a look to see meter's working. If I can see, let's do it under the microscope, let's do it that way. I want to see if I can figure out where that 0.3 and 0.7 actually go to. That's the wrong one, get the right one. And I'm moving it. Okay, that's the meter. That's that. Isn't microscope working? Yeah, the microscope's working. Just need to make a bit of space on my bench so we can see everything. So there's a test meter. Put that under there somewhere. I'll move it out of the way a bit so I've got a bit of space. It's test meter on ohms, yeah. This is the board, yeah. If you guys think I go too slow on this stuff, I know these videos can get long, but I'm trying to teach. If you guys, you know, come in the comments, tell me, say, Mitch, you know, come on, just speed it up a bit. Let me know. If you think they're just right, let me know. If you think I don't explain things enough, let me know. Okay, so the 0.7 volt was coming in here. Yeah, it was on that one. So where's that go to? Let's leave that on there and see if we can move this. Where's that go to? Doesn't go to that one because I'd see 0 ohms. Doesn't go to the one underneath. Okay, can you see it? Where are we? Yeah, there's those 2 there, yeah. 0.7 doesn't go there, doesn't go there. Some more over here. See them in there. I'm back on that capacitor again on the north bridge. Doesn't go there. Doesn't go there. That looks like it could be a regulator. This has got no coil here, but I'd imagine that these capacitors. Oh, huh! Just brush past it. That's what you want with an instant reactive meter. Capacitor there. So these capacitors are on the output of this, and that's the one that's 0.7 and should be 1. This will probably be the input capacitor on the other side. Does that go to one of these coils? First we've got to find out which end isn't ground. I'm on ground, you know, this end will probably be ground. Yes, I know it's on it. This will be on the input voltage. Input capacitor, regulator, output capacitors, yeah? But we can check from the chip, which we will do. So that's there. Found it. Found it. That comes from this one over here, onto that capacitor. There, yeah. And to prove I'm right, let's go back over here. No skullduggery here. This is the capacitor where we saw the 0.7, and I'm on that coil. I'll keep the meter probe on it, yeah, without moving it. I'm on this coil over here. Yeah. So that's giving you the 0.7, and that's giving you, that's right. That's giving the 0.7, yeah. And we've proved from this coil goes the input capacitor on this one, and this is dropping it to 0.3. So I was correct. Because this is only 0.7, a third of what it should be. This has only got 0.7 coming in, a third of what it should be. Sorry, not this one, third of what should be coming in, so a third of what should be going out, 0.3. That's exactly how it is. Okay, so next thing is, why is this coil here only got 0.7 volts? Well, that goes to this thing, HBK 676. Yeah, I think it goes to that because it's right next to it. I say it goes to that, but I'm sure you probably recognise these circuits now, that there's a controller very near to a coil. Yeah, goes to that thing. So that's the controller. So I suspect the problem with this, to be quite honest, is there's two things. Either this controller's got a fault, or there's like not a short circuit but a low resistance on this to ground, yeah? But if that was the case, I could check that should get hot. But let's check. So 100 meter on ground, yeah? And this is the 0.7 volts, it should be 1.8. No, it's a high resistance, there's no short there. So it's looking seriously now like this thing here has got a fault on it, giving too low a voltage. Can we find the data sheet for that one? That's the next thing we need to do. We zoom in. I think it says HBK 676. Okay, we need to find the data sheet for that. I expect that's an SMD code. I'm expecting that we'll have to somehow find the SMD code, then from that we'll have to find the part number then for the data sheet. HBK 676. Before we do that, let me just want to chat to you guys about something, what we've just done, about how we found this fault. And because we found this fault because we had another board of the same chipset, yeah, and we measured some voltages which thought they weren't right, and then we just compared it with the other board, and we could see that we were exactly correct, that those voltages were wrong. But would we have been able to find that fault if we didn't have a board to compare it with? Would we still be able to determine that we had a fault there? How do we move this thing? Yeah. I'm better at fixing stuff than working out software. Okay. We know how we found the fault, because I was measuring voltages, saying we need to have this powered up and we need to have this powered up on standby for it to switch on. It doesn't. So 3.3 volts there. I'm looking, I said possibly 3.3, possibly 1.8, maybe even 1.1 here, and we found less, 0.7, 0.3. I've never seen voltages below 1 volt on a working motherboard, not as I can think of, really. So that got me suspicious straight away. But without that experience, and then obviously being able to compare with a good board, could you find it? Yeah, you could. You'd have to be suspicious of those voltages, and I'm hoping now from what I've taught you that if you ever see that, you're going to be suspicious of those voltages, yeah? But what if you're suspicious of the voltages but you're not sure, I wasn't sure, and you haven't got another good board? Well, good, same chipset. Right. First thing you could do is look up the datasheet for this chip and see if you can find the datasheet, and in the datasheet it should tell you what the power rail voltage should be. So if you can find the datasheet for that, you can look it up that way, yeah? But something like this chip, Northbridge, you might not, depends the age of it. So let's say you're unlucky and you can't find a datasheet for that, yeah? Can you still determine if the voltages are wrong? Yeah, you can. Do what I did. Test meter and find out where they come from. Once you know where they come from, have a look at the controller. That one, and there's another one on the other one. Yeah, look at the controller. This one. No, not this one. It's this one over here. Look at the controller. Now that'll be one of two things. Yeah, that will either be a fixed voltage regulator, so it'll say input 3.3, output 1.8. It'll tell you. Yeah. If it doesn't tell you that from the data sheet, the output of this will be set by 2 resistors probably, and the ratio of the two resistor values will give you the output. And the data sheet will tell you how to calculate it. And you can measure the resistors and calculate what the output should be. That's method 2. Yeah? Method 3, go on the internet forums, bad apps, EveBlog, and ask, anybody see one of these, could you tell me what these voltages should be? So that's 3 ways you can find out. Are they right or are they wrong? Fourth way, if you're really stuck, you'd have to stick this on one side till you come across another board with the same chipset and then compare the voltages, which what I just did. Buy another board, another 40, and hope it's not the same problem. However, you may have to stick it on one side. So that's how. Well, can we find a data sheet? That's the question. I can tell you now, this isn't actually a part number. And this is experience, because I've seen them before. I may even have these available. I've actually seen these before, and I've had to replace these before, which is another good reason why this is likely to be faulty. So this marking, when you see like this line HBK and some numbers, yeah, that's not actually a part number. And the reason I know this is because when I first saw one, I couldn't find a data sheet, and somebody on the internet told me how to do it. These like 3 letters, 3 numbers like this. This is a company called MPS, Monolithic MPS, who actually, I think it's Monolithic Power Systems, who make voltage regulators and have these funny SMD codes on them, yeah. And they use a particular way, and basically the first 2 letters HB will be the product ID. That'll be the part. That'll refer to the part number, yeah. And the rest of it, the K676, is like a date code or a batch code. So what we need to do to find this one, and the only way you're going to know this stuff is just from not be able to do it and go ask on the internet, and somebody clever than you will come and say, oh yeah, that's a such and such. But we know it's HB, and we know it's a buck regulator, yeah? So what we're going to do is, we're going to search for that. So we're going to go into Google. And we're going to go HB, because that's the product code, yeah. And we're going to go MPS, because that's the manufacturer, we know that. HB book, yeah. See, I've searched this before. HB book regulator, yeah. And it tells us that's the part number for that one. It's MP2329C. Product code MP2329CGG. That's the part. So I've seen these before, MPS. That's the device. And if you see one of these, anything like that again, just search for like MPS and then the first 2 letters, yeah. And hopefully, if you know what it is, like a buck regulator, that'll help. And that's how you'll find these things. If not, look, you have to do like I've done before. Go and ask on the internet. Bad Caps Forum, and I'll show you that website. That's my favourite. And there's 1 or 2 others, and people know this stuff. Okay, so look, this is the regulator, yeah. We've got a voltage coming in. This will be the standby, 5 volts, I'm guessing. And in this case, coming out is 3.3 volts, yeah. And it goes on to show you there's a feedback and there's 2 resistors here. Let's just make it a bit bigger so you can see, because I know this doesn't focus perfectly. So voltage in, output's 3.3 volts, but we need ours is 1.8, and there's 2 resistors here, yeah. And those resistors, I'll tell you now, they'll actually, depending the ratio of these 2, will actually give the output voltage. They'll control it to go into the feedback. Oh, this shows you how it works. Year code, yeah. Yeah, so HB is a product code of that. Look, HB product code, this, yeah. Year, that's the letter, that's the K is the year. LLL is the lot number. That's how you decide for them. So, funny device, 11 pins, look, 3 underneath, 8 down the sides. Voltage in. Operates from 4.5 to 24. We've got 5 coming in, we know that. Yeah. switch output. This drives the coil. Switch and boost. This capacitor, not quite sure. What's that one? The ST. Oh, it just says you need to put a capacitor there. I don't care why. You need to put a capacitor there. Feedback. An external resistor divider from the output to ground tapped to feedback sets the output voltage. That's what I just said to you, yeah? So, these two resistors here will set the output voltage. So what can go wrong with this? Well, if one of these resistors changed value, that could cause it to be wrong. But I doubt it, because there's so little power coming through these. That's very unlikely to happen. But yeah, keep in mind, if a resistor here has changed value, that would change the voltage output. And that's really it. Enable pin. I think it's probably just permanently enabled hours. Yeah, that just tells you it goes to ground or something to switch it on. Enable pin. Turns it on or off. Enables high to turn it on and low to turn it off. Well, we know ours is running, so that must be high. It can't be anything else. It must be, it is working. Wrong voltage. So we found our problem really. We've either got here a faulty chip or a faulty value resistor. I can't see much else that can go wrong with it. And my opinion is it's much more likely to be a faulty chip than be a faulty value resistor. So I think what we'll do with this is change the chip. If you change the chip and it's still wrong, then yeah, we can start looking at this sort of stuff. But in my experience, that is much more likely to be what the problem is. Okay guys, so that's that. I think I may even have these parts in stock. It's one I've come across before, and when I have come across before, by the way, it is actually the chip that's faulty. It is the chip. So what we'll do is we'll change that chip, which is going to be fun because it's so close to the end of these, and we have to use hot air to change that, and we don't want to melt the ends of the DIMM sockets, so that's going to be good fun. But we'll get by. We'll change that chip, and then we'll see if it works. If it does work, if we get the right voltage on here, I'm confident this will power up. If it powers up, we can try the CPU and get it to run. We can try the post analyzer card and see if that works. If we get this one running, then we'll have another look at the other one to see why that one isn't running. Okay guys, hope you enjoyed that, and I'll see you soon on another video where we're going to change this part and we're going to see if it works. Cheers now, see you guys.